All right. Thanks, everyone. Can I start?
Well, I just want to confirm, Megan, can you see the presentation in presentation mode?
Yes, it looks good.
Okay.
And
all right, it's working.
David, take it away.
Okay, great. Thanks for having me. Thanks for tuning in. My name's Dave, and this is the title of the project that we worked on this summer, Mount Rainier National Park Sensitive and Imperiled Bryophyte and Lichen Inventory. Slide, please. My name's Dave Kofranek. I'm a non-vascular botanist. I've been studying bryophytes and lichens for almost 30 years, and I've been working professionally with them for over 20, all over Oregon and Washington, both sides of the Cascades, and Alaska. And I'm a consultant, a taxonomic expert for the Forest Service and BLM for bryophytes. Whenever something potentially rare is found on the land that they manage, it comes my way, and I identify it and verify it. Slide, please. What are bryophytes? Bryophytes are, I think we all have an intuitive sense of what a moss is. So there's two other things that are moss-like that are bryophytes: liverworts and hornworts. These are the first land plants. They're primitive, but not necessarily simple. And identification can be challenging, needing multiple microscopes. Slide, please. Why do we care? The park is has an increasing number of visitors. There was 1.75 million visitors to Paradise Rainier Park in 2021 alone. So there's a lot of impact, especially trampling. And non-vascular plants haven't been formally surveyed in the park ever, although there have been some famous collectors sweeping through decades ago, but nothing for a very long time. Slide, please. Project goals. These are the goals that the park has to conduct the inventory of rare and sensitive species of these records that were very old. They wanted to know where they were and if they're there or not still, so that they can protect and monitor them in the future, avoiding their areas during construction projects. And we also collected data using plot work, and they would use this data to recognize and confer potential areas that are rich with species or might potentially have rare species. Next slide, please. Next slide, please. Our study areas were 5. We had 3 low elevation coniferous forests. The top left, the Carbon River had a palpable oceanic influence, and the bottom 2 right, Cedar Flats and Ohanapekosh, were also low elevation coniferous forests, all old growth. And then we had 2 subalpine forests, or subalpine habitats, Sunrise and Paradise. Next slide, please. Some snapshots of these areas: subalpine on the left, and then the low elevation coniferous forests on the right. Thanks. Random selected plots. We had 2 types of plots, randomly selected, and then we had intuitive plots in case we came across an area that looked rich or had potential of having the rare species in it. We had the choice of doing a plot there. And then we just had intuitive control meander, where we were free to kind of follow our nose and our experience and seek out these good habitats and find species that way. These 2 methods complement each other very well for thorough results. Next slide, please. Results. These things are hard to identify in the field, so we collected 700 packets of just bryophytes and over 1,000 identifications of just bryophytes. This resulted in just the things we collected were 143 species of mosses, 55 liverworts, and a hornwort. Next slide, please. And next slide, please. We had, this is the list of species, the rare species that we were supposed to look for, and the ones that we found are in bold. There's actually 7, not 6, like it says up top. But and then 2 bonus species that weren't on the list originally, but are significant. So that totals to 9 out of 23 species, which is nice, but I was hoping for more. This rare species list is an all-star list for a nerdy bryologist like myself, and there were many things I wanted to turn up there at the park and that didn't. And things like Bryophyte, Brachydontium, Tetradontium, things not only rare and exciting, but morphologically unique, and would have been really exciting to see those. And so it, it made me wonder, why weren't they there? Where were they? Where were they first seen in the 60s? And of course, visitation has its impacts, and that might be it. And or there's a lot of stonework in the trail system there in Paradise, for example, where these things would be. And was that stone sourced from the trail side? Were those things growing on the stone that are now steps on the trails? I had to wonder about that. And of course, there's climate change and air pollution. We don't know. Things to consider. Next slide, please. This is one of the rares we found. This was not on the list, but Grucia belanderi, apparently new to Washington. That's exciting. It's an ephemeral, so maybe that's why it hasn't been found before. Found by John Villela, our lichenologist, who's on deck right after me. It was found in this habitat below, along with Polia cardodii. This is at Paradise. Next slide, please. Conostomum tetragonum, also at Paradise on this vertical rock face. You might be able to, it's very unique. You might be able to see a kind of a star pattern of it on the top right. Next slide, please. And Thamnum necoroides was found at also Paradise, protected rock surface, and tip-up mounds at Cedar Flats. So both high and low elevations, kind of a nondescript species from a distance. But next slide, please. And Encalypta brevicalis on this fog-swept ridge crest at sunset. This habitat on the right there was very rich with lichens. John will probably touch on that. Next slide, please. And the famous one that everyone gets excited about, Schistostega pinnata, growing on the bottom of this tip-up mound on the right. It likes very dark and shaded, moist conditions, and the unique fronds on the left. Next slide, please. And Matt, this is actually a little short video if you want to try to attempt that down at the bottom. This is just the other part of Schistostega is a filamentous part that is reflective. And I tried to take a video of that. It's called Goblin's Gold and is reflective. It's pretty neat. It's as spectacular as a moss potentially can get. So that's neat. Next slide, please. And thank you, Beth Fallon, our contact at Mount Rainier. I believe she's the one who came up with this. Wondered where are all these rare things that were found so long ago, and how does go out and find them? It was a great opportunity. Thank you, Hazel Galloway, for organizing this, keeping us on task. That was great help. Tom Lindsay, Longmire Campground host, very friendly. Siskiyou Biosurveys with my crew right there. We all worked well together. And yeah, thank you very much. Next slide, please. I guess I'm ready for questions.
All right, so again, raise your virtual hand or put your questions in the chat. We have one from Miles, and as you were talking, I was like, oh, I hope even Miles can talk. Our previous presenter. I'm probably not going to say this right, but he says, what was the aspect of the site Conostomum tetragonum was found?
Good question. It was west. It was a little surprising. Miles talked about north-facing things, and I absolutely agree with that. And both Sunset and Paradise are predominantly south facing, so it was really hard for us to find out smaller areas. You know, if an outcrop was facing north or something, that's really what you wanted to find, to look for the good stuff. So this was a west facing, but it seemed like it was still shaded by some trees, and it was extra cool there. So it wasn't your typical west facing aspect.
Well, I'll ask a question, and I apologize if you already mentioned this, because keeping time and doing all this is a little distracting, so I apologize if I didn't hear. But was this a project that you approached the park with, or is this something that they were looking to learn, or was it kind of both?
Well, I think it would be everyone like myself's dream job opportunity, but they contacted us. Beth Fallon, I think she's the park ecologist, and she wanted, there are, dozens of records of rare bryophytes and lichens from the mountain, and a lot of them were seen in the 60s, 50s, 40s, and not much since. So she must have got to thinking, you know, where are these things? And we need to protect them if we want to build a trail or whatever, at least monitor them. I don't want to speak for her too much, but it's just very reasonable, understandable interest in it. And then, I could go on, or if there's more questions.
No, I mean, this is really interesting in how it can inform those park management decisions.
Yeah.
John asks, a couple just came in. Okay, John asks, thanks for the presentation and your work on these rares. For these species, for the species you were surprised not to find, do you think that there's still some likelihood they're out there in different conditions than you might expect?
Yeah, thanks for asking that. I meant to mention that. Yes, so now we've surveyed the 5 most popular parts of the park. Now the next step of the project, if there is a next step, I'd love, if there would be to visit more pristine areas, places that people don't go very often. That would be a whole nother ball game, and a great increase in the chances of finding these rare species.
Robert asks, bryophyte work sounds like working in paradise, so to speak. Are you monitoring for climate change?
I suppose this is some a starting point. I'm a taxonomist, so I can't go too far into this, but what we have now are 2023 records of what's there and what's not, and so and plots, and people are free to revisit those periodically and see if anything changes. We do have records from the 60s and things. They're not, the location is very vague, but that is also a starting point in some ways. That's as much as I can answer that question.
No, that's excellent.